Oh my goodness, we are live. Welcome, students, teachers, those that are joining us. We have an incredible 75 minutes ahead of us. Have no fear, you're not stuck just with me. We have a whole bunch more guests hiding backstage. We just have a couple little housekeeping items to take care of first, and then we will meet your crew that will take you through this next 75 minutes where we are going to build our own rocket ship and learn more about the Artemis missions. If you are brand new to these lessons with us, we always start things off with a land acknowledgement. So I'm based here in Calgary, in Alberta, Canada, and people came before me, well before me, but we have a rich heritage of nations like the Blackfoot, the Piikani, the Kainai, Tsuut'ina, Stoney Nakoda, and the Métis are here in these lands, and I just want to send my thanks and gratitude for those that came before me. If you are interested in finding out who was on the lands prior to you, take a look at that link on the screen, native-land.ca. It's really just a great way to just stop and reflect on who was here before us. Well, with that, who am I? Well, I told you I'm in Calgary, Canada. My name is Michelle Armstrong. I am the co-founder of the Cobblestone Collective, and the Cobblestone Collective is a group of teachers that get to help teachers and students like you with all things technology. And we have some of our team backstage ready to work with you. But before we do that, we couldn't do any of this without Minecraft education. We are a partner to Minecraft. Yay! We get to help them launch cool worlds like this and teach students like you. So thank you, Minecraft education. Warning, students, before we begin, you have some work to do. Guess what? This is recorded. It's coming to you via YouTube Live. You can pause at any point. So this is for you, teachers. Hey, we get a bit excited. If you need to pause, you can pause at any point. We'll be here when you get back. And of course, the recording will be here forever and ever. Maybe some of you are watching us on the recording now. Thank you so much for tuning in. So that means you can see and hear us, but we can't see you. But guess what? We can hear from you. And here is the magic, students. Here's your first job. Take a look at that link on the screen. There's actually two of them because sometimes that first one doesn't work. But try that first link. Go into a new tab on that device in front of you. Type in the cc.page/Minecraft. It's going to take you to a Microsoft form where I want you to tell me what is your first name and where are you joining us from. And if that first link doesn't work, have no fear. We can do our troubleshooting. Try plan B, and it's bit.ly/CC Minecraft form. It's a little bit longer, but either one of those will work. And we have Donna is here and Kim is here. Miss Dozier's grade 2 class. Welcome. Hema and Jennifer. We've got Washington, Seattle, Miami. Oh my goodness, we have so many students here. Have no fear. Students, you'll get some shout outs. If you keep that form handy, you'll be able to speak with us. All right. Well, I mentioned you won't be stuck with me. Thank goodness. Two of the guys that are going to take you through this world are going to join us on stage right now. We have Darren Malte and we have Dan Noble joining us. I'm going to let them introduce themselves in just a second. But at the Cobblestone Collective, we couldn't do what we do without current educators or consultants like these guys. So huge shout out to you guys. Darren, let's start with you. Why don't you give a quick intro? Tell us where you're from and your favorite food.
Oh my gosh. Hi, I'm Darren, and I work with students and teachers in Alberta, Canada. And my favorite food is probably pad thai.
Ooh, yum. Yeah. Me. All right.
I can't believe all the people all over Scotland. There's people in England. There's people all over the place. Trillium Woods Elementary School. Hi, Haley. Great. And joining us is my good friend, Dan, who is just one of the most amazing Minecraft builders his job is Minecraft, if you can believe that. So when your parents or your teacher saying you can't do that for a living, you can. And this guy can prove that. Hi, Dan.
Hi, Darren. Hi, Michelle. Hi, everyone. My name's Dan Noble. I am a member of the awesome extended team here at the Cobblestone Collective. And as Darren said, I am a full-time Minecraft education consultant. So what that means is I do lots of content builds. I do all sorts of workshops like these, and I do all sorts of in-services and PD and things like that. And I'm currently located in Dumfries, Scotland.
What? Love it and love that we can be working with Darren from Alberta, Dan from Scotland, and all of you students. We have Nolan and Riley are in Ontario. So is Evan Hahn. We've got Patrick Henry Middle School, 8th grade. That's Valentina told us that. Students, let us know in the forum where you're from, and hopefully we'll get to getting shout outs to all of you. But we have one more guest from with us. Also not from Canada, not from Scotland. I believe he is somewhere in the United States. And guess what? He's from NASA. We have a guest speaker here who is going to hang out with us for the whole lesson and hopefully teach us all sorts of cool things. Hey, Martin, how are you doing?
Great. It is great to be with you folks today.
Now, Martin's going to give a brief introduction of himself because I read his bio and I kind of had trouble figuring it out, but let me see if I got this right, Martin. So you're a speech writer. So you write stuff, you write manuals and things too, I think, and it's for SLS Crafts. I had to look it up. You basically work on information about rockets that put people into space. Am I close?
You're very close. Close enough to count. That's exactly right. I work for NASA's Space Launch System program. The Space Launch System is the rocket behind me, which left Earth about back in November. But I have a long history. I worked in newspapers for many years as a science writer for several. And then I got a job working with NASA. And most recently, as you say, I can do speeches and presentations. I'll help the engineers do them. I will write papers for them for professional societies that they go speak to. We will do verbiage that goes with pictures and videos and all sorts of stuff.
I like that you just segued right into my next slide. Pictures. Pictures are very important. Now, you said you wanted your profile picture to be something more like George Clooney or something, I think is what you mentioned. But instead, our master builder, Dan Noble, he created you inside Minecraft. So this is your new profile picture, Martin. We hope you like it.
This is great. I'm going to put it on my government badge.
I love it. All right. Well, students, we have Martin here with us who works at NASA. This is your chance to ask Martin whatever questions are coming to your mind right now. Darren, can you just tell me, give a few more shout outs? Who's here? Where are they from?
Super interested in video games. Tristan doesn't say where. Oh, Martin Berkeley. Oh, sorry, he's shaving his Tristan saying hi to Martin Berkeley.
Still here. Hey.
I have a question, Martin. Out of all that writing you've done, what is the most incredible moment that stands out? Is there like one moment that that sticks with you that you think back on?
That's incredibly easy. I have been a space geek since I was 5 years old.
Yeah.
And always wanted to be part of a rocket program that left the Earth and went somewhere else and explored. And so when that rocket went up last November 16th, and I stood there about 3 miles from the launch pad and saw that thing go up and could claim a little bit of that was me, that's the crowning achievement of my professional career.
I got chills. That's great.
Yeah. Amazing.
We do have some questions coming in. Students, definitely get your questions into the forum right now. Now's your chance. We're going to wait for just a couple more questions come in, but I'll bet you, Dan Noble, I bet you have a question for Martin. Am I right?
I have probably too many questions. Like yourself, Martin, I'm a huge space geek. I've been following NASA space exploration my whole life. So you've watched this launch from 3 miles away, and I remember people talking about Saturn V and how just like explosive that launch was. Just the pressure being released from the launch, and really being you're sitting there watching it and being hit by that sound. How does the space launch system compare to that? Do you think did you feel that those vibrations and that sound hitting you as you were watching it?
Sadly, I never saw a Saturn V launch live. I'm told it's similar. The Saturns had these big engines on them that had a very low rumble, but SLS, the boosters, have this very snap, crackle, pop sound as they go up. And yes, from 3 miles away, you can feel it like hitting you in the chest like that.
That's amazing.
All right. We definitely have a lot of very, very eager students who have some questions. Let's go with question number 1. These are all science-based questions. Well, let's start with maybe Brandon. Have you ever been to space? How did it feel? Or do you know someone who's been to space? And can you comment? How does that feel?
I haven't been to space. I would be glad to go up on SLS anytime they ask me, and I'd call you guys back and talk to you. But I have had the privilege of talking with many astronauts before who've worked on various programs that we've worked on. I met Neil Armstrong, the first man on the moon, Buzz Aldrin, the second man on the moon. They are just incredible people.
Wow.
And if you know the technology, they're very brave people. This is not an easy job. You have to be ready for anything. And many of them have several college degrees. And they're impressive people. Just if they weren't astronauts, they'd still be impressive people.
Right? No kidding. Well, yeah, awesome. Well, that was it was Adrian asked that question, as did Brandon. So thank you for those students for that question. Now Miles has a question. Miles wants to ask, how long do the missions last for the astronauts?
Well, of course, that depends on I go way back to the beginning of the space program. SLS, on the first launch last November, it was an uncrewed test launch, and it lasted for 2 weeks. Now, on the real missions that'll carry people, they're going to have missions of about 2 weeks long, which will include going to the moon, going down to the surface, and coming back. It takes several days just to get to the moon, even at 24,000 miles per hour. It takes that long to get to the moon. So about 2 weeks is the short answer.
Wow. Students, 2 weeks. Just think, what have you done over the last 2 weeks? Well, to be on a mission for that long. Very, very cool. You know what? I think we're going to maybe ask one more question now. We're going to dive into Minecraft, and seeing as you're sticking around with us, Martin, we might throw a few questions at you all throughout. But one more question.
Do you have I like Maureen's question there, Michelle?
I was just going to ask Maureen's question. It's a great question. Maureen wants to know, what do kids need to do to prepare to eventually work at NASA?
There is the idea that you have to do math and science. And it is true that engineers and scientists do lots of math and science, but there are many jobs. There are people who do accounting, people like me that do communications, other people that maybe do facilities, keep the facilities running, the buildings and stuff running. There are a lot of jobs. All of them, though, require that you focus in school and take math and science is great. The ability to communicate, that's your English and spelling, that's important to you. You need to be able to do all those things. So that's just a rough idea, but there are many things you can do and support the space program.
That's really great to know. So students, hopefully you've been inspired. Keep those studies up, but lots and lots of opportunities out there. Well, with that, we are going to be logging into Minecraft, touring around the Artemis 1 world. It's going to be Dan and Darren who are going to be your co-pilots for that. I'm going to hang out backstage. I'm going to take Martin with me, but Martin's going to be back to answer some questions throughout. So with that, teachers, if you need to pause at any point to get your students caught up, just remember you can do that. And I think, are we going to go over to your screen share now, Dan?
Dan's going to rock it out.
All right.
All right. We're going to let you take it away, Dan.
Okay, so here we are. We're logged in and ready to go. And to get to our Artemis world, we're going to click on New and Featured. And I've already got my astronaut avatar picked. I've got my spacesuit on. I'm wearing my NASA cap here and my Minecraft t-shirt. So we're all ready to go and ready to rock. So we are going to select Artemis rocket builds. That will be the third tile along. So just go back there, make sure that we've got it. So click play, or sorry, click New and Featured. And we're going to Artemis rocket build. And when you're ready, you're going to click Create World. So my computer might do this a lot faster than yours. I'm using a gaming computer, so it's pretty snappy most of the time. If it takes a few seconds for you, that's okay. Just be patient. It will load. There are some extra bits and pieces that it needs to get started.
It's got to load rockets. So you might see it loading the resource pack and it taking a little bit of time on this page, right?
And I just love this world. Visually, it's stunning. And just look at these screens.
I think Martin's over there to the left. If you look up in the bleachers, he might.
Let's see if he's up there somewhere. Give a wee wave. Okay, so we're just going to start talking to NPCs. So we've got an instructor. We've beamed right in front of the one that you want to talk to start our mission here. So it's welcoming us to launch control. I'm not going to read this verbatim. Just give you a quick summary of them as we go through that. But I highly recommend, it's one of my failings in life is frequently when I'm reading stuff, I just gloss over it. You know, it's really important, particularly with this particular activity, to read everything that the NPCs are saying, because there's a lot of really important information in them that you're going to need to refer to later on.
Yeah, and to interact with those NPCs, Dan, you're just right-clicking on any of the NPCs and
that's right.
Yeah,
right click. If you are using a Chromebook and you don't have a mouse, you can use what we call the snake bite, which is a 2-finger tap on your mouse pad. We'll do a right click. And just a quick intro here. If you haven't seen it before, Immersive Reader. It's
so cool.
Available on all the NPCs. It's this little book and little speaker icon here. If you click this, it opens up Immersive Reader, which is one of my favorite tools in Minecraft because it will read everything the non-player character is saying to you. And there's some settings here. So if you want to slow down the voice speed or pick it up a bit, you can do that. You can change the voice selection. You can click on specific words and just have those read. Something will give you pictures. Also, really other cool thing Immersive Reader does. So if I click on this book icon in the top right corner here, oops, something went wrong. There we go. Sometimes that doesn't happen very often, but it does occasionally. Most of the time it recovers right away. So we can click on this book icon here and we can translate it. We can translate all the script into all sorts of different languages. So for example, if I just picked, let's say French Canada here, and I click document,
boom.
And once I toggle that on, it's all translated into French. Not only is the script in French, but if I press play, it will read it back to me in French too. So Immersive Reader is a really powerful and great, useful tool.
Yeah.
So let's just click the arrow at the top here on the top left. If you click that, it'll take you back and away from Immersive Reader.
Yeah. And we would hope that you'd come back and spend more time reading these things and interacting, because I see there's a cryogenic engineer in this room. So you can talk to those people later on and get more information, even though what Dan and I are doing is a bit faster because we're doing a live show.
Yeah. So let's click next. Okay, some special classes that are just going to take us through all the basics of building our own rocket. All right, so we're going to be sending some cargo and even people to the moon. And our first mission will be launching a satellite. So this is going to be important for helping our astronauts communicate with us back on Earth while they're at the moon.
Perfect.
Click next.
We have a lot of Martin questions here in the chat.
All right, let's head down the hallway and start our lessons. And as Darren mentioned, there are so many other NPCs that we could wander around and talk to here. So there's a lot of information. Okay, so as we approach this classroom here, and you do have to go through the classrooms. If you run to the end of the hallway here and try to jump ahead and skip ahead, you won't be able to. The elevator doors will not open. You do need to complete the classes first. Okay, so we'll go to lesson 1, an introduction to the Artemis. Okay. So here it's going to tell us about the Artemis missions. Okay, so this is important. NASA is going to land the first woman, a person of color, on the moon as part of these missions. And use new technologies to explore more of the moon than ever before.
So this is a good question for Martin, maybe too. It's going to be a different spot than the Apollo missions, obviously.
Mm-hmm. And if memory serves, I believe one of the destinations they're hoping to get to at some point is the Shackleton crater on the South Pole, where there's potential reserves of ice water under the lunar regolith, which they can potentially use not only for oxygen and water for drinking, but also for fuel for rockets. So how are we going to get back to the moon? So we have a number of buttons here that we can press on to explore. Let's click on Discovery. So we're learning what we've learned from space exploration for more than 50 years. And we're looking at the Apollo missions were essentially sort of scouting missions. Artemis is about going long-term.
Mm-hmm.
Okay, and there's going to be a space station around the moon called the Lunar Gateway, which is going to support lunar exploration on the surface. Okay, Artemis missions will create new jobs and industries on the moon. So maybe somebody out there listening today might end up with a job working on the moon. That would be very cool. That's something that I wanted to do all my life, but I don't think I'm going to get that opportunity.
Yeah. All right. We can probably get through this. So why go to the moon? Discovery, economy, inspiration.
Okay.
So there's some reasons.
Now, once we've gone through all those, we can move on to our next classroom.
And you definitely have to talk to these NPCs to go through and get the doors to open. So you're not trapped in a classroom.
I can't get out there.
Can't get out. Okay. How does a rocket work?
Okay. So this one definitely have to pay a lot of attention to here.
Oh my goodness.
Oh, I need to get a little closer. There we go. Talk about the basics. So we have special laws. Newton's laws understand how forces work and how to make sure rockets fly properly. So these were written down a long time ago by Sir Isaac Newton. So in the 17th century. But they're still important for rockets and engineers today. So let's learn a little bit more about Newton's laws. So objects like to stay still or keep moving unless something acts upon them.
And these laws are even more important in space, because a good example is if something's moving on Earth, gravity and the friction of the air is going to slow them down. But in space, once you go on a trajectory, it's a vacuum. You can be going forever with even a little bit of thrust, right?
Mm-hmm. So that's the first law. Second law. Speeds up or slow down or changes depends on how much mass and how hard it is pushed. So second law of motion. So if we want to make a rocket go faster, we can either make it lighter or we can add more thrust, more boosters. Okay. Third law. equal and opposite reaction. So when something pushes or pulls on something, the second thing pulls or pushes back just as hard. That's how we make things move. So hot exhaust flows about the back, forcing the rocket to go up. Reaction is produced. Okay. So let's click next here. So we're not done yet. We have a lot more to learn about rockets.
So we got these forces pushing and pulling, different direction. So this is really important when we're talking about the weight of the rocket and how much thrust is taking you out into space. You have to have enough to get you up into space and get on the right trajectory. And it's just incredible how the Earth's gravity is just such a strong force that we don't think about. So we got the weight and the thrust here.
Okay, so let's click on weight. So weight is the gravity creates on an object. Gravity creates mass to have weight and what makes things fall to the ground. Okay. Weight can be different on different planets.
Which is why when you see those astronauts in the Apollo missions bouncing on the moon's surface,
yes,
they have less weight on the moon.
That's right. So it's 1/6 Earth's gravity on the moon, if memory serves.
Chippewa Lake School is already in room 3, and the other half are planning their rockets to take off. Okay, we better
hurry up here. Okay, so thrust is a force that makes a rocket move.
Perfect.
Okay.
I love this, you guys. I'm going to pop back in, and I brought Martin back with me. And I love to hear that we've got some students that are way, way, way ahead. That's the coolest thing about Minecraft. Students, you can take this at your own pace. Dan's going particularly slow because we know sometimes we get way ahead of ourselves, but it's super cool. Some of you are way beyond us. Let us know in the forum. How are you doing? What lesson are you on? And okay, we're back to Martin. We've just learned a whole bunch of things from these folks. Any comments, Martin, on anything you've seen so far?
This is all great. I really want to go play the thing myself now because it looks so cool. There was a question about what it takes to work at NASA, and I did mention education. But, you know, one thing about the people who work there, including the engineers, but everybody, they ask lots of questions.
Ooh.
And when they get answers, they challenge the answers until they're satisfied they know the correct answer in its entirety. So have curiosity, develop curiosity. Never stop asking questions.
Fantastic.
Yeah, that's excellent.
Oh, and did you mention, Darren, they were asking where it was going, where the next missions were going?
Yeah.
I know the Apollo missions all were along the lunar equator because it's easiest to reach that in terms of your fuel and everything else. Now, the Artemis missions are going to the lunar South Pole. Never been explored, but it's really interesting for one thing because we think we can find water there. We spotted water there with robot spacecraft. And so we want to go there and take a look for ourselves. And so that's the next place we're going to go, but it's very cold. So it's even colder than it is along the equator. And so it's going to be harder there to stay warm.
Yeah. And one of the students said, the famous explorer, when Dan said Shackleton. Yes. The
famous
explorer of
the
South Pole, Ernest Shackleton. And they found his ship there and stuff. All right, Dan. So that's how a rocket works. Can we go into the next room and catch up to some of these students?
And exactly, Darren, I'm also going to mention. So Dan, why don't you go ahead? You keep talking to those NPCs. You get your learning on. We're going to get our learning on with Martin while you're doing that. So we'll kind of watch you navigate. But Martin, Madam Stewart's grade 6-7 class at Trillium Woods in Ontario wants to know, have you always wanted to work at NASA?
Yes, and yes. Wow. I remember when I was little, I grew up on a farm, and my older brother got a farm set when he was, 5 or 6. He was 7 years older than me. When I got old enough to have a farm set, my dad gave me one, but I wanted to play with space toys. And so I have been a space guy since I could remember.
That is awesome. We have a question for Dan from Maggie. Have you built a spaceship in Minecraft before? Maggie, you should see what Dan has built in a very brief thing. Dan, what have you built? Dan, I know I saw your space your lunar lander and the crater you've built?
Yeah, so I did build sort of a makeup model of the Shackleton crater, just a miniaturized version with a lunar landing module and like a crawler for exploring the lunar surface. But actually, one of the very first things I ever built in Minecraft was a model of the Saturn V and the launch tower.
Beautiful. So we've learned about velocity and delta V. And delta V, just to keep it short, is the force you need, the thrust you need to get off and escape Earth's gravity, which I'm not sure if I think it says there the math. Basically, you have to go, is it like 50,000 kilometers an hour or something like that? It's a massive speed. Maybe Martin would know in miles.
Oh, I can't do. I'm sorry to say, I can't do the conversion because they didn't switch to kilometers and things till I was older. But it's about 17,500 miles an hour just to get into orbit, and then to break orbit and get to the moon is about 22 to 24,000 miles per hour.
Oh.
And of course, when you get to the moon, you have to slow down, so you have to turn your rocket around and fire the other way.
Yeah,
of course. And students, spoiler alert, all of this information we're learning from Martin and from the NPCs. You're going to put all of this learning into play when we get to go over and work on our own rocket ships. Well, with that, we are on lesson 3, and I know we have some students already in the elevator, already at the already at the actual spaceship. Okay.
Now, they might have skipped every single thing. The one thing that's cool here that Dan's saying, liquid and solid, they act very differently. The solid boosters, when you turn those on, it's almost like you can't go back.
That's right. You can't throttle.
You can't turn off the gas and unthrottle. So it's important to think about those things, right, Martin?
Yes. In fact, there was an astronaut who rode the space shuttle, which had boosters, solid boosters. Yeah. He said, when those things go, you feel like a bone in a dog's mouth. Wherever it goes, you're going with it.
Yeah. So that's some important things they have to think about when they're launching the SLS and they're creating these things. Just the kind of fuel, the weight of the fuel, how that fuel is going to act, all these
and all the safety that goes into making sure that it operates right every time.
Yeah, exactly.
We're going to ask. Oh, sorry, we've got a bunch of questions coming in that's the same question. So students are dying to know. And Joshua even said, please. But we have Michaela and Joshua, and I think it's probably all of Madame Stewart's class. Do you like working at NASA? What's it like?
I love working at NASA. The folks there are great. They're incredibly smart. The engineers work very hard, and yet they have time to share their knowledge with me. So a lot of them also do double duty as teachers to me and some of the other writers that work there. But it's always interesting. It's to just sit in the meetings that you would think might be dull. They're incredibly interesting because they think of things that you never thought of before in terms of planning a mission into space. There's a million things to plan and think about, and they think of all of them.
And you're just learning all the time. You mentioned that. Like, I think that's so cool that you continue to learn while you're working. That's awesome. Cool. Excellent. Well, with that, I wonder maybe, Martin, you and I can head backstage again for a bit. We'll leave this to Darren and Dan to see if they can get through the lessons.
All right.
Students, let us know how you're doing. What lesson are you on? And if you're having any troubles, let us know in the forum.
We're on the last room here. What's next? And our last NPC is just going to talk to us about the 2 missions. So we already had the one last year, which is our first test launch. And then the next one is also going to be unmanned, taking us around the moon and testing out everything. And then the third one, this is incredible. We're going to have students. Yeah, go ahead, Dan.
Sorry. The second one will be crewed.
Crewed, but not landing.
It will be a crewed launch. It'll be like Apollo 8. It will do a trip around the moon and then come on back and test out the flight hardware during that mission. So I'm quite excited to see that because I wasn't old enough to see Apollo 8. I'm really excited to see Artemis 2.
Can you believe? I'm so anxious about the pictures we're going to be able to get.
Oh, yeah.
The famous, like the Earthrise picture from like those are famous. We're going to get some of the most amazing quality images, I think, from those missions that are just going to be astounding. And students, this isn't that far away. 2025.
Yes.
This is in 2 years. We'll have Artemis 3, a manned mission to the moon a crewed mission to the moon. So unbelievable.
And first time since 1972. Again, I was born in 75, so I just missed everything. And I'm just so excited to see humans walking on the surface of the moon again and exploring and discovering.
So cool. Well, let's go build a rocket, Dan.
Yeah.
Okay. Space launch rocket.
Just talking about the Gateway station here. So the Gateway is a place where we orbit the moon and will help support much more capable missions than Apollo was capable of back during the 1970s. So exploring southern regions, potentially other places away from the equator that are a little bit more challenging to get to and require more resources. And we'll be building a boot camp somewhere on the surface of the moon. So a surface station. So it's quite exciting times ahead. I've been waiting for this all my life.
Okay, well, let's find out what's ahead of us in the elevator.
All right. Here we go.
While we are in the elevator, so students, hopefully you got to the elevator. We're going to bring Martin back. He does have a comment about pictures that you mentioned. Martin, you put it in the chat.
Yes, if you go on to nasa.gov and maybe type and maybe also Google, say, Artemis 1, you will find a link to pictures that were actually taken robotically by the Orion crew spacecraft. It had a camera sticking out on its solar panel, and it took pictures that showed the moon and the Earth in the background of Orion, because it went something like 27,000 miles beyond the moon. And so you see this picture of a tiny moon and Earth. Earth is still bigger in the background despite being so far away.
Oh my, I have that up, Michelle, if you want to. I can show mine.
Perfect.
Well, do you know what, Darren? I wish we had like 3 hours for this, maybe even more, because we could probably do so many things. But right now, I bet we have a bunch of students wondering, okay, what are we doing building and testing a satellite here? So students, if you are head down, if you have gotten to this part, we want to help explain it a bit. I had trouble with this part myself. And so teachers, if your students aren't at this point quite yet, you may want to pause the feed until we get everybody down the elevator to our first satellite, because this puzzle is going to help us get down to the rocket where we get to be building. So with that, I think I'm going to leave it to Dan and Darren to take this on.
Do you think, Dan, let's do it wrong. Let's make it so we have a very powerful booster and a very small payload and see what's going to happen. Like, we know what's going to happen, but when we talk about that thrust, like, let's see what happens when we test a rocket that's going to be within our budget, but, you know, a giant amount of thrust and a small payload. So what would happen if you do that?
So we've got our buttons here, so we can cycle through the different components. So the bottom components are our engines and boosters, and we can see how much thrust they're going to provide us, but we have a budget to work with too. So I've just picked some solid rocket boosters here, and we are way over budget, so I can't pick that. But the second part, and we can cycle back and forth. So now we're down to minimum. And this is our second one here. This is how much fuel we're carrying. So we can change the core stage that carries all that fuel, and we can cycle through that. We can go back and forth. And the top is our payload. So we're launching a satellite on this one, and this is the mass of the payload here.
That's cool.
So we're going to, again, we have to keep within budget here. So I'm going to try to do something terribly wrong here, but within budget.
Yeah.
So let's see if we can do
smallest boosters we can do.
We'll do the smallest satellite that we can do.
Exactly.
Lots of fuel. So we're still way over budget here.
So those big boosters, I think they're just taking the cost way up.
Okay, so let's see what we can do here. We got one big booster there, one solid rocket booster, and we've got our liquid fuel here. Yeah, and we've got our liquid engines at the bottom, and we've got our satellite. So let's go over here, and when we're ready, we'll
And I
click
suspect
test,
what's going
and
to happen.
we'll
Dan
see what
probably suspects
happens.
the same thing, that we are probably going to get out into space.
Okay, so
right?
far too much thrust. We have escaped not only Earth gravity, but the Earth and Moon system, and we're now in a heliocentric orbit, lost for all time.
See you in 1,000 years, maybe, if you get pulled back in by the gravity of the sun. So we don't want that. So we need to find a balance between probably the proper flaring, proper thing we want, and the amount of fuel. So something like that might be getting closer.
We'll try that. We'll try that. See how that works.
This looks pretty good.
So it's a little bit of trial and error here, going out and trying to figure out. Oh, okay, and we didn't get off the launch pad. So this is essentially, we're experimenting with rocket components here and seeing which ones work well and which ones don't. Okay. And it's very much like early space exploration when they were developing these things in the first place. And you've probably seen movies of some of them going up and then not going anywhere. Okay, so we need more thrust here. So let's try that. That's too much. Let's try that one, and maybe try that. 45. Let's see. 45 out of 50. Let's see if that does the job.
Cool. Oh, this is a good Martin question. I like this. NASA's main focus right now.
Here we go.
Boom.
Okay, we got into orbit.
I wonder, Dan, so you got into orbit. Any chance you can go back just to show any students that might be struggling what the magic components are? You might not be
no, unfortunately, there's no back button. So once you've clicked test and you move on to the second part, that's kind of it. But the magic number there was the budget. So if you cycle through, so the top one was the smallest payload that I could put on there. It was just a little conical one. And then the budget was 45 out of 50. Okay. So I think you can get it closer than that, but
the next two Artemis rockets, you can get them exact and they work well. Right on the budget.
Right, so let's talk to our instructor here. So we're going to redesign the upper stage here any way we want. So I'm going to maybe make a little satellite here, and I'm going to do it inside the fairing here. So I'm just going to get inside the conical fairing and make myself a little satellite.
Well, before you do, so we know you're a master builder, Dan. We are looking at this satellite. I'm going to go back to you, Martin. What might its purpose be?
There are lots of things that it could be. There are a lot of Earth satellites that study Earth's environment and are studying that now. But then too, you can also send space probes to the planets. And we have sent probes to every planet. I thought it was a good question about using a large rocket and a small satellite. That's actually is something that we've thought about, because if you don't have a heavy satellite, you can send it to the planets in maybe half the time of a smaller rocket. So you get there faster. You don't have to worry about micro miniaturizing your satellite and making it super efficient for electricity. There are several advantages that you can take advantage of.
Makes sense. Okay, Dan, back to the Minecraft side of things. What are you doing here? You're not building, you're breaking. What are you thinking here?
So I am using that outer shell fairing that's going to protect my satellite during launch from the atmosphere. Because if I just strapped a satellite on top of a rocket without anything to protect it and sent it up, likely those forces of pressure from the atmosphere on the satellite would break it up, and it wouldn't be particularly useful once I got to orbit. So I'm going to keep my fairing here on the outside. It's something that would be jettisoned once I got to orbit, and I'm going to build my satellite down here. So let's go into my inventory, and I'm going to grab some blocks here.
And you are a much better student than me, Dan. I just picked pretty color blocks and I just switched things around. And I think I maybe drew a heart on my satellite. I thought, isn't that what you need to do when you put things into space? I feel like you're much more scientific with your building than I was.
Nothing wrong with getting decorative with your space vehicles.
Yeah,
rather than just utilitarian.
We are going to be painting it in the next little part of our build too.
Mm-hmm. So sometimes we don't have all of the things that we would necessarily like. We don't have actual rocket parts. So I'm using stand-ins for what I'm going to be using here.
Oh, well, wait, we have an expert here as well. What would be some elements that would be on a satellite, Martin?
Well, you've got to think of structure because it's got to survive launch, even though it's going to space. So it has to be strong enough to survive launch. It has to be able to be very efficient because it's got to provide its own power for as long as you want it to be in space, whether that's 10 years or maybe 50 years. It's also got to have communications so the ground can receive pictures and other things from the spacecraft and send commands up. It's also got to be hardened against radiation. And that's just a few of the things.
Yeah. It's so fun to watch Dan build these things because he's using trapdoors and stuff, and he's totally creating some things that would be inside a rocket.
Some students get the hand to do that for industry.
Look at that. Some of the students just want to know, how are you, Martin, and do you love your job? I think you've already said yes. Yeah,
very much so. And it gives me the chance to talk to folks like you.
Yeah. And Joshua's like, what's your annual salary? Joshua really wants to know what it's like to work for NASA. Josh, you have to go to NASA to find out. Oh, this is a great question. Dan, do you ever put secret messages in your designs? I know the secret messages sometimes when you're creating things are called Easter eggs. And boy, does Dan have some cool Easter eggs in some of his build.
Yeah, I do like to sneak in a lot of Easter eggs. They're frequent references to pop culture, things I've done. Some of the space builds I've done will reference all sorts of NASA history. So I'll talk about different spacecraft or space probes or astronauts. And one of them actually hit like a little miniature museum, which talked about all the famous women scientists and mathematicians and engineers that have contributed to the Apollo program. So that's something I really wanted to highlight.
Martin, one of the students was asking who your favorite astronaut was. We don't have to play favorites, but maybe who was an astronaut that you thought, wow, what an inspiration to me, or what a powerful person in their job and in their life. Which astronaut maybe really stood out for you?
Of course, Neil Armstrong is a big one since I was a kid when he landed on the moon.
Yeah.
And even after he came back, he was very inspirational even when he came back and spoke to people. Another astronaut would be like Hoot Gibson, who flew many shuttle missions and continues today to talk to students about his experiences and about space exploration.
Yeah. Oh, I love this question from Madison. How long would it take from the planning to the actual construction of the rockets? What sort of time frame? We had the launch last year. When did that rocket build start for Artemis 1?
That program was just stood up in, I think, like 2011 or 2012.
Wow.
And so it has taken that long to actually design, build, and do probably the most extensive test program since the Apollo program to the moon in the 70s. Now, it depends on what you want to do. Other rockets that maybe that go into Earth orbit may take less time, and maybe you can save some time by using existing parts. If you're trying to develop some totally new propulsion technology, it may take you longer, things like that.
Cool. All right, Dan. Now, Dan's spending a lot of time here. I really hope the students come back into the world and go through a little bit more with more discussion and try to do something like Dan's creating here. Things with switches and what did you build here, Dan?
So what I've got going on here is I've built a little communication satellite, and
cool.
I'm using different parts here to achieve that. That aren't. Oops, I've just broken one.
There's no undo in Minecraft. Control Z. No,
that's right. There's no undo. So, like, I'm using a a hopper and a cauldron here for my propellant and engine, which will help me raise or lower the orbit and control the spacecraft while it's in orbit around the moon. I've got some solar panels here along the side to provide it with energy. Then we got some core sections here where we probably keep the computers and electronics, and we've got some instrumentation here. Like I've got a little aerial, a little lever again is another little like instrument maybe hanging off it, and then I'm using an iron trapdoor and copper lightning rod as my communication dish there.
Now, I wouldn't have had all these ideas that Dan has. I probably myself would have gone in and maybe just hollowed it out at the very least and maybe put a few things down, maybe some glow. I put glow stones. I'm a simple man. So maybe students want to do a more simple thing. If you're understanding what Dan's doing and using some of these other parts, you can by all means like put some other things down. I'm sure some students just rushed through and did the painting part, because I know I probably the first time I know I did. Yeah. Oh, that's cool. Dan, you're gonna need some maneuvering thrusters to keep it in orbit around Earth or Mars. Oh,
right, so let's see if I can add some here.
This is why you have the NASA person here. Get some thrusters on there.
Not gonna let me put them on.
Oh no, because you have trapdoors on as the build, right? Yeah.
Yeah. So let's see here. Yeah.
And students, while Dan is navigating there, adding some super cool stuff, let us know in the forum, what did you do with this first build challenge? How did you make it your own? Just let us know in the forum. We'd love to know some of your ideas and what you're building. Hopefully you're getting inspired by Dan's amazing.
It's super cool too. Like, look what he's using. So Michelle, what are your materials there? Dan, that is not an actual thruster, even though it looks like a thruster. So you're using metal bars and some.
Yeah, it's not quite as thrustery as I'd like it, but I think it'll do in a pinch.
I think it's amazing. Should we go to the painting component of the first one and just see what students are doing? All right, let's talk to our NPC and let's get this thing painted up with some nice bright colors.
Well, and while we do that, Martin, you just left a note in the chat, which I think is really important. Do you want to let the students know what you just said? Yeah, about the color.
Yeah, I think maybe in Minecraft it'd be cool to maybe design your spacecraft and build it and change the color to represent the insulation that NASA uses on the outside of all its spacecraft to protect all the delicate satellite parts against the extreme heat and extreme cold and even the radiation environment in space. So that's something you could do that would be very NASA-like.
Yeah.
Yeah, so you could use a gold block for that or an iron block.
Cool.
Super fun.
Okay, so
now,
we're
this
moving
part's
on to painting.
This is a little less realistic because generally you don't want to spend money and time on paint, and paint also has mass, so you don't want to weigh things down with paint, right, Dan?
Yeah. Generally, if I remember correctly, they do not paint the fuel,
the
liquid fuel container. Sorry, for the core stage there. That's just left unpainted. I think the only time I know that it was painted was on the first shuttle flight back in, was that 1980? Maybe Martin would be able to confirm or correct me on that.
You're officially a space geek, Dan, because that's totally correct. They painted the first couple of external tanks on the shuttle and realized they saved hundreds of pounds by not painting it.
Wow.
And those pounds transferred directly into payload they could put into space.
Absolutely. But we're going to paint ours. And Dan, yeah. Calvin says, very nice satellite design. So Calvin,
thank you.
Okay, right. This is super fun. Not necessarily what we do in real life, because like Martin just said, we don't want to spend our weight. So what you're going to do here, Dan, you have to make the paint bigger by pressing, I think, 6 or 5. 1, 2, 3, 4, 5 would make, or 7, would make your paint
so
large.
If you look at my hotbar here, I can shift the kind of color that I've got. I think I'm going to go with blue.
Hey, Dan.
And I can change the size here too. So I think I'm just going to add some nice little highlighting stripes rather than
that's nice.
A full paint job here.
The first time I did this, I just looked at this launch area and just how incredible, not the launch area, this area that we're in where they're building. This is such a cool build as well. If you look around and fly and look at the stairs and the size of it, Isaac is decorating Artemis 2. Yeah, that's Artemis. Yeah, that'd be 2, I think.
Oh, they're already on Artemis 2. Okay, excellent.
Yeah.
Okay, so yeah, I'm just adding a couple of blue stripes here. I'm not getting too
Sorry,
fancy.
Dan, I was inspired by your satellite. I thought it was very good.
Thank you.
Get some good ideas for what to put inside.
So we've got a couple of stripes. I think that looks pretty good.
I like that NASA blue stripe. That's
what I was thinking.
Yeah.
Right. So I'm in creative mode here, so I can fly around like normal, but I'm just going to come crashing back down. So I'm gonna get down fast here, and we're going to launch this rocket here. So let's talk to our instructor, and it's done. So let's go for launch.
Can you give us a little with your microphone? Yeah. Or maybe Martin can give us a little countdown here.
NASA, this is mission control. You will go for launch. Begin fueling.
And Dan, you can be the other part.
Okay.
Dan wanted to put the old Apollo beeps, whether the comms into our last beep. Yeah.
And while this is also loading here, Martin, I'm wondering, does this look similar to you? Like, can you envision those similar boards or that similar room somewhere in NASA?
Oh, absolutely. It's very much like we mission control in Houston that takes care of the astronauts and runs their missions. We have a similar control room at Marshall Space Flight Center where we watch every screen is dedicated to some piece of data on how the hardware is performing.
Wow. Wow.
This bit I love. I love how they start pouring the water in there.
Oh, that's a great simulation.
Very cool. And there we go.
Okay, well, now this is from a non-space nerd. Why are they pouring water in there? I'll go to you with that one, Martin.
They pour water in for a couple of reasons. One, when those boosters ignite and then the liquid rockets go off, there's a huge blast wave, acoustic blast wave that could potentially damage the rocket, that does damage the mobile launcher that it sits on. So it knocks down the sound waves. It also helps cool the deck of the launcher so that it doesn't burn up. So and burn up is extreme, so that it doesn't damage or warp anything like that. So it's got a couple of purposes.
Wow. Yeah, I had no idea. Students, look at like the power of Martin's knowledge here with us with Minecraft. All right, Dan, well, we've been through build challenge 1. How many more build challenges are there in this first world?
So we have 2 more that you can go through. So the second one, we will be launching cargo to support our missions in orbit and on the surface. And then our final mission is to launch a crew to the moon.
All right. Well, with that, I'm going to head backstage again. Martin, I think I'll take you with me because students, chances are you're head down doing your own building. I think we challenge Dan to go into the second build challenge and wow us with some Minecraft building skills. What do you think? Okay. Challenge accepted. Call us back if you have any questions.
That was very nice. I really enjoyed the countdown. We actually won one of our schools. We created some badges for the Canada Space Agency, and we won an uplink. So one of the astronauts from the Canadian program came, and we did an uplink with Houston and the ISS.
Oh, okay.
We had the
cool
Houston though, the Roger. Yeah, it was one of the coolest experiences for those students. And one of the students wore a spacesuit that he had. It was very awesome.
Oh wow. Okay. So when you're ready to go on to the next mission, just go back to the instructor at the beginning here, where you get placed after the rocket launch. And we can click next.
Yeah.
And I love go through all this.
If you're spending your time and you're making it colorful and awesome, that's fantastic. Because Kaylee, the idea is we want you to get in here. And if you get a few, if you're someone like Matthew, who has a Saturn V manual, Matthew might want to go into some of those details about the rockets and really those sort of things. If you're just wanting to make it more colorful, you're still participating in this space program just in a different way, because we do need designers, we do need engineers, we need writers and speechwriters like Martin. We need all kinds of different people to make these rocket missions a success. So we need, Dan, correct me if I'm wrong, we need a larger liquid booster. We need larger payload, because this is where we're going to have cargo, and probably even a larger solid thruster. We have 160 gems.
Got a little bit more to work with here for our cargo.
Yeah.
All right.
This one,
yeah,
I
and
know
as Martin mentioned earlier, you know, like there are so many different types of professions that are involved with this. There's just so many different things that need to be done and taken care of.
Yeah.
And there's a role for many people to play in many ways, and ways that you might not even consider. Like, it's not just the rockets themselves. You need the support infrastructure that goes along with that. So the crawlers that take it from the vehicle assembly building out to the launch pad, or those pumps that push all that water out, that we're talking thousands and thousands of gallons a second. I mean, that to me is just so amazing that somebody has developed a system to do that. Okay, so let's look at our, so we need a little bit more. We need more fuel, and we need more payload. So let's go with, I'm going to go that's a nice big fairing there. That's a lot of space for that we could put cargo into. And let's see here. Still doing pretty good there. 102. That looks good. So we're going to need some boosters on this one.
Yeah. Liz, your student should probably be able to press the space key twice to fly up.
So double tap the space bar, hold down on that second tap, and that'll get you flying up in creative mode. Okay, so we've got some good solid rocket boosters here at the sides, and we've got a good amount of liquid fuel. Let's just stand back there. So we're using 154 of 160 budget. So
looks pretty close.
I'm gonna test here, and we'll see if we get off the ground and get to the moon on our first attempt. Test there.
I wonder if your payload's too big, but no, with those. Let's see.
Oh,
okay, cool.
There we go. And we've got our cargo setting down.
Cargo down. Sweet. Dan, Isaac's asking if you've ever been in any building tournaments or challenges.
I have not been any. No, I have not been in any challenges myself. But I have done content builds, and I've judged contests.
Oh, cool.
So I've been involved that way. Although that's the thing, most of the contests are for students. So as an adult, I'm automatically disqualified, which makes me so sad because some of these contests are so interesting. I'd love to be involved in them, but I can't.
If your students are having trouble with any of those combinations, if you pause and look at Dan's successful build, that can be one you can just leave that on the screen or take a screenshot and keep that up, just so you can, because it's a little bit of troubleshooting going back and forth.
So that one we had a budget of 160, and I think I was using 155. So I just pushed those buttons really until I had 155. Now that said, I was using the biggest fairing at the top there.
Yeah, I thought it wasn't going to get off the ground, but then you had the big solid booster, so I wasn't sure, but yeah.
So I think I was pretty much maxing out my options there.
I noticed
we are sending cargo to the moon, so we've got a big amount of space to work with here. And I've got to walk in here before I can go into creative mode. And I find this is really cool. Like, I can walk over here. I'm in creative. Walk over here in survival.
That is so cool. And if you just look at the scope of this thing is easily 10 times the size of the first one you were in.
Yes, I've got a lot more room to work with here.
Yeah, and it gets dark.
It does. I'm gonna need some lanterns.
There you
I'm
go.
gonna grab some sea lanterns here.
Oh, those are gonna look awesome. Those would look awesome on the exterior, actually. If you were.
There we go.
There we go.
So we are just gonna. I don't know if I'm gonna be able to. What's our time like here? How are we doing for time?
We have about 12 minutes. Matthew's American. I think Matthew's American, red, white, and blue for the NASA and American Space Program.
Oh, very nice.
Isaac is designing Artemis 3, and you can use 190 emeralds, and that is true. If you get it to exactly 160 for Artemis 2 and 190 for Artemis 3, it'll give you the perfect one. There's even is this the one where there was the creeper payload?
Yeah, you could use the creeper payload.
Yeah. There's a little.
Right, so I'm just clearing some space out here inside my fairing. I'm not going to have enough time to do anything too big, but I'm going to try to build like a little cargo lander, or like a lunar truck, as it were, that'll get me down onto the surface with my cargo.
Oh, so fun.
Going to break some more blocks here.
Martin was just mentioning in the chat, and maybe Martin can talk about that. The fact that with this, the the next mission, they're going to have that gateway space station at the moon, which is going to help us get to the moon more easily in future missions, right?
And we can, that's the thing, we can have astronauts stay over on Lunar Gateway. They can leave spacecraft, like if we have a lander that's going to be reused from going to the gateway to the station, it doesn't have to come all the way back to the Earth. We can just keep it at the Lunar Gateway. It's ready for this as essentially a taxi down to the surface whenever we need it. It's going a lot further than we ever did with the Apollo systems.
Do you want to touch on that, Martin, about the gateway and what that looks like and its purpose? And
Sure. The gateway is going to be, it'll be a little smaller than the International Space Station that we have now. But by being around the moon, it can serve as a way station for spacecraft coming and going. That could be smaller spacecraft from Earth that maybe can't get into low lunar orbit, which you have to do before you can land. And it will also simplify the ability to send smaller spacecraft down to the moon without having to go to low lunar orbit. I'm grasping to explain it, but it serves as a waypoint between craft coming from Earth and craft going down to the moon and coming back.
Zach built a payload of fish and axolotls.
Well, there may be some life sciences to be explored there at some point. Sending, ants and small animals to the moon to do research there. I know that in the past in the International Space Station we've sent spiders and ants and various creatures. I think they've even sent up. I can't remember everything they've sent up. There's been so many over the years. The International Space Station's been up there for over 20 years now.
So this is your little mod. Okay, that's pretty cool. Martin, sorry to put you on the spot, but one of the students is asking roughly how fast Artemis 3, like its maximum velocity. Do you know around how fast it's going to get?
They'll all have to go at least 17,500 miles an hour or so to be able to go into orbit around the Earth.
Yeah. Does that increase when they get to space?
Yeah. If from orbit, in order to break Earth orbit and head to the moon, you're going to have to do 24,000 miles per hour to get there. And then you either have to use the gravity of the moon to sort of slow you down, or you have to break into fire braking rockets to get into lunar orbit. And then, of course, when you come back, Orion has a heat shield on the back. All that energy you gained with SLS and the upper stages and Orion has to be burned off before you can land. And so that's what Orion's heat shield is for, is to get you back to Earth safely and convert all that speed into heat.
Awesome. And Kaylee's asking when these missions are. And I think, so last November was Artemis 1, next November is Artemis 2, and then the following, is it all November?
And now that's really kind of dependent on partly when they get ready. And they've got to get all the parts to KSC, to the VAB that you guys have designed, and put all those parts together and test all those parts. It's a long process.
Yeah. Have you ever been on a mission where it was scrubbed because of weather?
Oh, in fact, Artemis 1 was scrubbed a couple of times due to weather. In fact, once they had hurricane force winds that came through. Whoa. And they elected to leave the rocket at the pad rather than risk it being caught between the pad and the vehicle assembly building. And it weathered it just fine. There were maybe a few little places with the blow-on orange insulation maybe came off in a couple of places.
Yeah.
But it survived very well. It wasn't full force hurricane. But yes, I mean, you can't launch in certain winds because the thrust can't compensate for that and steer correctly. It may be lightning. You don't want lightning to strike your vehicle and make your computers go wacky. So there's lots of weather constraints.
So cool. Do you happen to need a Minecraft builder at NASA? Because look what Dan is building. I'm astounded by his speed and what he's building. Dan, you want to walk us through a little bit?
I'm ready to swap places with him. That looks like fun. I want to do what Dan's doing.
Me too.
I always get put on the spot and racing against the clock here. So what I've got is my lunar truck, which is going to bring down stuff. It's a cargo lander. So we do need a way of communicating and controlling it. So let's put a little communications array on it. There we go.
Can you pause for 1 second? Give us the whole view so that someone could like screenshot and get some ideas.
Yeah.
And
so
those are a solar panel.
Yep. So I've got my daylight sensors, which are my stand-in for solar panels.
Trapdoor.
And I've got some engines and thrusters on the bottom here. So that's for our landing. So again, I'm using cauldrons, and I always use cauldrons and hoppers for my engines on rockets.
It's very
and
cool.
I've got some slate fences here, walls. I'm using them as my landing legs. So we've got 4 of them on either side there. And I need to do something with the top here still. So not sure what we'll do. Maybe put some iron there.
Cool.
And sadly, of course, I'm the one that's got to come in here, the bearer of bad news. We are almost out of time. Dan, it's always incredible to watch you building, and students, I hope you're also inspired by Dan. Dan, I'm going to switch off from your screen just to go back to our students. So students, let us know in the form, what was the coolest thing about this lesson today? And I'm going to start just by saying, I went through this world. I didn't really understand like all the payload and actually building things inside of the rockets, but to watch you, Dan, and to actually see how much thought you put into it, how much you know about space and NASA. I mean, you've inspired me to go back and try again, maybe do a little better, but yeah, super, super cool. So that was my favorite part.
Right, Michelle? We have the second part because we built the rocket. And then some of the missions in our next one, we're going to be coding and doing some of the awesome astronaut type activities. I'm so excited for that too.
Spoiler alert. We'll talk about that in a second, but I want to give a few shout outs. So Kaylee, thank you for being here, and love that you love learning. Calvin, you love the rocket building part. Me too. I all of these shout outs. So Sinclair is here. You guys have been so interactive with us, and it really helps us. So I've got to say, thanks to Zach and Mason and Matthew R. and Isaac and Liz and Peyton and Jackson, Damer. If we didn't say your name, gosh, we hope you'll join us in more lessons. Darren, what was your favorite part?
Oh, just between the big brains of Martin and Dan, I'm squished here. I just love being able to interact and ask questions and to talk to someone. Now we're 1 degree away from someone who's met Neil Armstrong. So I've met Martin. Martin has met Neil. So I love that. And
fabulous.
What the students are saying there. I love this. This was so fun. This was so great.
Yep. So, Martin, do you have a highlight? Anything you learned today?
I am just knocked out by the world that you guys have created here. It's incredibly close and good to the world that some of you guys are going to see when you go to work for NASA, building rockets and flying missions to distant planets.
Yeah.
It's just amazing. I really want to swap places with Dan, at least for a month or two.
Well, now I know, Dan, I don't believe you were involved in building this NASA world. Huge shout out to Minecraft Education, of course. But hey, Dan, I think you do know the builders that were involved, but their names escape me. Do you happen to know offhand?
There was a company that was hired to produce. I don't remember the name of it offhand, so I apologize.
No, and that's okay. I know I saw some tweets about it, but congratulations to Minecraft Education and the world builders, because it truly is phenomenal.
Tom's highlight was watching Dan's creativity, and me too. I love the lunar rover you just made. That's really, really cool.
Yes, excellent. Well, students, here's your next steps. We want you to go back and talk with those NPCs, learn from those NPCs, go back, try building different things, different configurations in those test scenarios. And then this is what Darren was hinting at. We sure hope you can convince your teacher to come back and join us on the 29th. So that's next Wednesday, where we're going to be coding and making sure that our rocket ship doesn't crash and actually gets to the moon. So hopefully you will join us on the 29th. Teachers, if this is the first time you've been with us at the Cobblestone Collective, check out that link. We do so many more lessons kind of like this. We'd sure love to have you back. Again, like I mentioned, huge shout out to Minecraft Education. We are the Cobblestone Collective. We are super thankful to have had you here, Martin. So thank you so much for being here.
Thank you, Martin. Good to see you.
And with that, students, we hope you'll continue to do your building, continue being inspired by space. Thank you, Dan. Thank you, Darren. And we hope to see you all again in another lesson very soon. So with that, we will say
Take care.
goodbye for now.
Thanks, Kaylee.
Bye, everyone.
Awesome. Thanks, Isaac.